Representing direction for vectors. First of all, recall that a vector has both magnitude and direction, and that the magnitude of a vector is indicated by the length of an arrow that is drawn. Direction is indicated by the direction that the arrow points. So the first step in representing a vector is to choose a scale that will make it convenient for drawing the arrow within the space you have on a sheet of paper or, say, on a chalkboard. In some problems, motion occurs in one direction only, or one dimension, and so the simplest type of representation would be to use an axis, such as the x-axis or the y-axis, to indicate the direction of a vector that lies along one of those axes. If a vector lies on the x-axis, then if it is pointing to the right of the origin, it's considered to point in the positive x direction, or if it points to the left, it's considered to be pointing in the negative x direction. In a similar way, a vector might lie along the y-axis. If it lies along the y-axis and points above the origin, this is considered to be the positive y direction. If it points below the origin, it's pointing in the negative y direction. Of course, these conventions might be changed for a given problem. We might also call these directions right, left, up, if it's in the positive y direction, or down, depending on what's given in the problem and what you might be asked to find. Another way of representing vectors involves bearings, although this is not a method that we will likely use in this course. If a vector has a particular bearing, then its direction is noted by measuring the angle that the vector forms with the positive y-axis. Compass bearings are used, starting with 0 degrees, and then 90 degrees, 180 degrees for a bearing that's pointing in the negative y direction, also known as south, or 270 degrees. So if we were to begin at the positive y-axis, moving to the right, the angle is measured with a protractor, and the angle increases to 45 degrees, and then 90 degrees, and so on, all the way around the circle, eventually coming to 360 degrees, or back to 0 again. Here I'll draw in a vector whose bearing is 45 degrees. So we measure it so that it is exactly 45 degrees away from the positive y-axis, also called north, depending on the problem you may be working. So the vector indicated here has a bearing of 45 degrees. In this physics course, we will be using reference to the cardinal compass directions. It's important to know where these lie on a map or on a page. By convention, north is always at the top of the page, south is always at the bottom of the page, east is always to the right, and west is always to the left. This is exactly the same convention that's used with maps. So for example, if I have a vector that is maybe 4-unit vector, 30 degrees east of north. First, I would have to choose a scale. And my scale might be something like 1 centimeter is the same as 1 unit. So using my metric ruler here, I'll indicate my scale. 1 unit equals 1 centimeter. So a 4-unit vector would be 4 centimeters long, an arrow whose length is 4 centimeters. The bearing given, or heading that's given here, is 30 degrees towards the east of north. That means this vector, starting from north, would be drawn in a more easterly direction by an amount of 30 degrees. So I would have to take my protractor and measure 30 degrees away from north, headed towards the east. It's important to be as accurate as possible. A 30-degree angle would be indicated here. My protractor reads 30 degrees here on the outer edge, but as long as you bear in mind that each large mark on this particular scale is 5 degrees and each small mark is 1 degree, you could simply look at these marks and count to figure out where your 30-degree angle would lie. So the protractor really could be used in any orientation as long as you keep in mind the value of the marks on the scale. My vector would begin at the origin, and now I need to draw a line 4 units long that passes through the mark I've made, indicating a 30-degree angle. Here's my vector. By convention, we will always use the smaller of the two possible angles. While it is 30 degrees east of north, you might also say 60 degrees north of east. But our convention in the book that we use is to choose the smaller of the two possible angles. In other words, to describe its direction in reference to the axis or cardinal compass direction the vector is closest to. The more you practice drawing these vectors, the easier this process will become for you.